Hello everyone. If you are running a restaurant or a hospital or any such service, you know how challenging it can be to manage calls effectively. The number of calls you receive at any given time can be unpredictable, leaving you with two options: overhire staff or make customers wait in long queues. Both are far from ideal. One drives up your operational costs and the other frustrates your customers. Overhiring increases your expenses while making customers wait results in poor satisfaction. So, how can we solve this problem? Enter AI voice agents. Imagine having an AI that can take calls 24 by 7, answer queries, and book appointments. With AI voice agents, there is no need to overhire because you are charged based on the minutes of call time. This technology scales linearly with demand, providing an instant response and a seamless customer experience. It's a win win situation. Customers no longer need to wait in queues, they get instant responses, leading to higher satisfaction. Your business saves on operational costs while efficiently handling fluctuating call volumes. So, how can you build your own AI voice agent using openly available APIs? In today's video, we will walk you through the process. So let's get started. An AI voice agent consists of three major components: speech to text, text based question answering, and text to speech. When the user starts speaking, we use the speech to text component to convert the audio into text. This text is then passed to a large language model along with the agent's prompt to generate the ideal response. Once the answer is ready, we convert the text back into audio using the text to speech component. For speech to text and text to speech, we'll be using DeepGram API, and for generating the response based on the input query, we'll be using the ChatGPT API by OpenAI. Before we deep dive into the code, let's have a demo of the entire workflow. Now I'll demonstrate how a restaurant AI agent can handle table bookings and take orders. Hello,
Good day. How can I assist you today?
I would need to book a table.
Of course, I can help you with that. When would you like to visit the restaurant and how many people will be joining you?
Tomorrow 4 p.m.
Sure, I can help with that. How many people will be joining you for the reservation tomorrow at 4 p.m.?
5 people.
Great. Your table has been reserved for tomorrow at 4 p.m. for 5 people. We are looking forward to assisting you.
So here is the GitHub repo for AI voice agent. So here is a demo of the entire thing that we have seen now. So these are the requirements. If you have to install it on your system, you would need at least Python 3.11 and you would need to get the DeepGram and OpenAI keys. And once you have these keys, what you need to do is you need to create a .env file in your project folder and set up these DeepGram and OpenAI keys. So there is already a .env file as you can see here. You just need to open this and copy paste your values here. Once that is done, you can come back and create a virtual environment. And once you have created a virtual environment, you can install all the requirements using pip install -r requirements.txt, and then you can run the app using python app.py, and we should get a demo similar to what we have seen previously. So here is the prompt for the restaurant agent that we have seen before. So we have given it a name James, and we have asked it to maintain a friendly and pleasant conversation with the user. So that is the personality, and we have also given it the task. The task is being a receptionist and take the orders or allow for booking of a table. And if they are looking for booking for a table, we have given it all the steps that it needs to do. That is, take the number of people who are coming up and what is the time they would be coming and all those details that we mention here. And for the menu, we give it the basic menu that is present, so that like the user can order based on these details that are present. This is the main function which does the major three tasks, that is taking the audio and formulating the transcript, and from that generating the OpenAI response, and then creating the audio back to play back to the user. So let's see how it works. Initially, we create a WebSocket connection with DeepGram using this API. Once that is done, whenever we get a message, this function will be called, and in this function we get the transcript. Once we get the transcript, we send the transcript along with the prompt to the OpenAI API. As you can see here, we are also having a memory so that it does have an idea what is the entire conversation. And once we get the response from the OpenAI, what we do is we generate the audio using the DeepGram TTS. So we'll be using this synthesize audio function. Once you go to this function, you can see that it makes a request to deepgram TTS URL, and it will generate the audio, and all this audio is stitched together to get the final audio. Once you get the final audio, you play it back to the user. But before that, you make sure that you mute the microphone. The reason you mute the microphone is because whatever the audio is being played, that should again not be received by the microphone and then send back to us. So that is the reason we mute the microphone and play the audio, and then we unmute it back. So this is how the entire process is working. When you are creating a deepgram connection, you are provided with a bunch of options, as you can see here. One major option that we are going to discuss about is the endpointing feature. With endpointing enabled, deepgram is able to identify what is the endpoint of the sentence and make the callback based on that. So this can be configured. As you can see here, I have kept 500. That is, after a delay of 500 milliseconds without any user speaking, it identifies it as the end of the sentence and makes the callback. So you can fine tune it based on your request. And what is the need for this? By using this allows you to create a end-to-end conversation just like you are having with a human, rather than AI breaking in between and responding back. So once we have the final audio ready, we'll be using Pygame library to play the audio back to the user. And once the audio is played back, we'll unmute the microphone so that now the user can speak back and it will be recorded back by our system. So that is how the entire workflow works. I hope this tutorial is useful to you. I'll share all the relevant links in description. And for more such awesome content, please make sure to like, share and subscribe. I will see you again next time. Thank you.